and Assalamualaikum everyone. For our group assignment case study, our title is a Scalable High Performance Enterprise Network Designed for Technova Solution Global Headquarters. For our group members, me, myself, Aina Zulaikha. My next member is PUTRI NURIZZATY, and our last member is SHARIFAH Zulaikha. So let's start with our presentation. Hi and Assalamualaikum, my name is Zulaikha binti HAIDI, and I will be presenting the network architecture for InnovaTech Dynamic City and Berhad. Okay, for our background company, our organization is a premier R&D firm specializing in artificial intelligence, AI, and advanced software engineering. With 200 high-level professionals operating in a 3-story facility, our day-to-day operation involves the transmission of massive, high-dimensional datasets. Therefore, a standard office network is insufficient. We require a high-throughput, enterprise-grade environment that can sustain wireless speed performance to ensure zero latency in our AI model development and R&D activities. Our design is anchored on 3 critical objectives. The first one, high performance and low latency. We aim to eliminate bottlenecks by providing a 10 GB backbone for data-intensive tasks. The second one is modular scalability. The network must support seamless expansion of user and IoT integration without requiring a forklift upgrade of the existing infrastructure. And finally, security and high availability. We emphasize 24/7 operational continuity and the protection of intellectual property through hardware-based firewalls and strict logical segmentation. Looking at the hierarchical design on this slide, we follow the Cisco 3-layer model to ensure fault isolation and predictable performance. At the first layer is the core layer. Core layer, acting as the high-speed transit point, the ISP gateway ensures rapid connectivity with minimal packet manipulation. The second layer is distribution layer. This is where the intelligence lies. We integrated an ISA 3000 firewall for deep packet inspection and a multi-layer switch to serve as the L3 gateway. And the last layer is the access layer. Access layer provides the edge connectivity for all floors. We utilize managed switches and Wi-Fi 6 access points to provide high-density wireless coverage. As you can see, we have specially highlighted the orange link in this diagram. This is our dedicated 10-skip fiber backbone connecting the server farm. This physically fast ensures that even during peak hours, our AI servers on the floor 1 receive prioritized physical bandwidth, preventing congestion from other general office traffic. Moving to our logical design, this design focuses on limiting broadcast domains and enhancing security. For VLAN segmentation, we have implemented 6 distinct VLANs: VLAN 10, VLAN 20, VLAN 30, VLAN 40, VLAN 50, and VLAN 99. This logical isolation ensures that departmental traffic such as finance VLAN 50 and AR&D VLAN 30 remain separate and secure. For addressing strategy, we use a VLSM, Variable LAN Subnet Masking, approach with a classic C private scheme. For operational efficiency, we designed a 1-to-1 mapping where the second octet of the IP address directly represents the VLAN ID. For the LT inter-VLAN routing, all routing is offloaded to the multi-layer switch. This allows traffic between departments to be routed at the hardware level, rather than via a traditional software router. Even though the orange link is a physical representation in my previous slide, logically, we have configured that the VLAN 99 server farm with high priority routing policies. This ensures our IP address 192.168.xx is internal infrastructure remains both lightning, fast and highly secure against unauthorized lateral movement. So that's all for me. Let's continue with my next member. Thank you.
My name is Sharifah Zulaikha, and I will move on to the physical network design. So, our implementation matched the logical plan to the actual building layout across all 3 floors. Okay, so for the first floor, we have the server room, which serves as the main distribution frame or MDF. This is where we place the most critical devices, such as the Cisco ASR router, the Firepower firewall, and the Catalyst 9500 core switch. This is the heart of the network. Next, for the second and the third floor, it has their own wiring closet, which we call the IDF. This contains the access and distribution switches that connect users in each department. For the cabling, we use a fiber optic backbone to connect each floor IDF back to the MDF, ensuring high-speed link between floors. Inside each floor, Category 6A Ethernet cabling connects end devices to the switches. This structured approach keeps our physical layout clean, manageable, and ready for future changes. Next, I will talk about internal networking devices. So, for our internal networking devices, we select the enterprise-grade Cisco equipment to ensure reliability, security, and scalability. First, the Cisco ASR1001X router serves as our gateway to the internet and handles VPN connections for remote access. At the distribution layer, we use the Cisco Catalyst 3560 multi-layer switch. This is crucial because it performs inter-VLAN routing at wire speed, which keep internal traffic fast and efficient. For security, we place the Cisco Firepower 2100 next generation firewall between the core and distribution layer. It inspects all traffic entering and leaving internal VLAN. For wireless, we choose Cisco Catalyst 9100 Wi-Fi 6 access point. They support high density usage and offer strong security with WPA3. All these devices were chosen because they are enterprise grade, meaning they are reliable, scalable, and built for business environment like our company, which is InnovaTech. For LAN technology and security, we focus on speed, segmentation, and control. In terms of speed, end users connect at 1 gigabit per second, which is plenty for daily tasks. But our backbone runs at 10 gigabits per second to support heavy AI data transfer and server access. For security, we implement several layers. Access control list or ACL on the distribution switch control what traffic can move between VLAN. For example, only IT can access the server room. At the access layer, we enable port security and DHCP snooping to prevent unauthorized devices from joining the network. And as mentioned earlier, the firewall sits between core and distribution to filter all traffic. Finally, we use quality of service or QoS to prioritize critical traffic like AI dataset and VoIP calls, so that business operation never slow down even during network peaks.
My name is PUTRI AUNI, and for my part, I am responsible for the connectivity, security, and network management components of the design. So I will explain how wireless WAN, remote access, and security mechanisms are integrated to ensure performance, protection, and scalability for InnovaTech dynamics. So the wireless network complements the wireline, particularly the access and distribution layer, to provide reliable connectivity for laptops, tablets, smartphones, and IoT devices across all 3 floors. So the network is designed to meet performance, availability, security, and manageability and scalability requirements. Okay, so the first one is the wireless technology, Wi-Fi 6 and Wi-Fi 6E. So InnovaTech uses Wi-Fi 6 with Wi-Fi 6E support for maximum efficiency in high-density environments. OFDMA allows multiple devices to communicate simultaneously. MIMO enables concurrent connections to many devices, and target wake time reduces power consumption for mobile devices. Wi-Fi 6E, operating in the 6 GHz band, reduces congestion from older 2.4 and 5 GHz devices, ensuring a fast and reliable wireless experience. Next is the access point placement strategy. Access points are strategically placed using coverage and density planning across all 3 floors, as shown in figure 7.2.1 to 7.2.3. Ceiling-mounted APs maximize signal strength and connection via power over Internet. Switches deliver both power and data efficiently. Overlapping coverage zones ensure seamless roaming for employees moving between floors or departments. Next is wireless security. So wireless security is critical, so we implement WPA3 Enterprise for strong encryption and use 802.1x authentication with a radius server for access control. So employees are assigned VLANs based on their department. While the guest network is fully isolated, figure 7.3.3 illustrate the wireless security architecture, ensuring confidentiality, integrity, and secure mobility throughout the headquarters. Next is the WAN service technology. For WAN connectivity, InnovaTech uses a hybrid approach combining dedicated fiber internet, metro internet, and MPLS. So this ensures high performance, redundancy, and scalability. Branch office connect to securely to HQ using site-to-site VPNs over metro internet or MPLS. So table 8.1 summarizes the key benefits of each one technology, including bandwidth, cost effectiveness, and reliability. Next is the remote access. So remote access is enabled via a dual VPN solution. SSL VPN allows individual users such as mobile or remote employees to securely access the network, while IPsec VPN supports site-to-site connection. For branch offices, multi-factor authentication ensures that only authorized users gain access, maintaining security while enabling flexible working. Next, security uses a defense in-depth strategy. So next generation firewalls enforce policy using the principle of least privilege, while the DMZ isolates public-facing services. ACL segment departments and control access between VLANs. IDS or IPS system monitor traffic in real time, blocking threats proactively, and all sensitive data is encrypted in transit to maintain confidentiality and integrity. Next, network management is centralized to ensure visibility and proactive fault detection. SNMP monitors device status and performance, sending alerts when the thresholds are exceeded. Syslog provides centralized logging for auditing troubleshooting. Enterprise tools like SolarWinds and PRTG monitor network performance and bandwidth, ensuring optimal operation and quick issue resolution. So in conclusion, the wireless WAN, remote access, and security mechanism work together to provide reliable connectivity, robust security, and high performance. So this integrate design ensures seamless operation for employees, support future growth, and aligns with InnovaTech's digital transformation objective. So that's all for our group. Thank you.